So for problem 1.2.15, we're using our densities as conversion factors. And so for problem 15, we're going to use our densities to turn volumes into masses. And if we start with part A, we want to convert 6 cubic centimeters of mercury into grams, and it tells us that the density of mercury is 13.5939 grams per cubic centimeter. Now that grams per cubic centimeter, when we turn it into a conversion factor, remember, means that for every 13.5 grams of mercury that we have 1 cubic centimeter of it. So we automatically put that one on the bottom. Our cubic centimeters are going to cancel out, and we're going to wind up with 81.5634 grams of mercury. For part B, it wants to know 25 milliliters of octane, which has a density of 0.702 grams per cubic centimeter. Recall from our work with our conversion factors that a milliliter and a cubic centimeter are equal to each other. So these two, we don't necessarily have to write the conversion factor. We can if we want to, but they are equal to each other, so they're going to cancel out and leave us with grams, and we're going to have 17.55 grams. Now, with both of these questions, you can stop and ask yourself, what you should be doing with all these problems, does my answer make sense? And in this case, having more grams than I had cubic centimeters of mercury makes total sense because the density is very large. The same is true for the octane, where I have 25 milliliters but only wind up with 17 grams. That makes sense because the density is less than 1. So it should be less than a 1-to-1 ratio of those two things together. Now for part C, I have 4 cubic centimeters of sodium. Sodium, it tells me, has a density of 0.97 grams per cubic centimeter. Again, I should expect an answer less than 4 cubic centimeters, and I do see that I get 3.88 grams. And then finally for part D, I have 125 milliliters of gaseous chlorine that has a density of 3.16 grams per liter. So I have to start by converting milliliters into liters so that my units are going to cancel out, and there are 1,000 milliliters in 1 liter. Then I can use my density as my conversion factor, 3.16 grams per 1 liter, and I see my liters cancel, my milliliters have canceled, and I get 0.395 grams of gaseous chlorine. This one's a little trickier to say, does my answer make sense? But if you think about milliliters of a gas versus how much that gas weighs, it makes sense that it's a very small number because that is actually a very small amount of gas. Now this gets trickier when we have to use our conversion factor to convert masses into volumes. And I encourage you to watch the solutions video for problem 1.2.16 to see how we handle the conversion factor for those.